Welcome to The Explainer. Today, we are pulling back the curtain on one of light's biggest secrets. It's this hidden property that's, believe it or not, all around you. It's the magic behind your sunglasses, it's what makes 3D movies pop. Yep, we're talking about polarization.
Okay, so how does this actually work? I mean, have you ever wondered how a simple pair of sunglasses can just erase the blinding glare off a lake? So you can actually see the fish swimming underneath. The secret here isn't just about tinting everything darker. No, it's way cooler than that. It's about literally taming the light itself.
All right, so if we're going to talk about taming light, we first have to get on the same page about what light is. Now, we've known for ages that light travels in waves. That's old news. But here's the thing. That simple fact leads to a really important question. What kind of wave are we actually dealing with here?
Is it like a pushing wave, kind of like sound, where the vibrations are going back and forth along the same direction it's traveling? Or is it more like a wave you'd make on a string, where it's vibrating up and down totally perpendicular to the direction it's moving forward? Well, thankfully, we don't have to guess. Way back in 1865, a discovery settled this debate for good. Turns out light is a transverse wave.
And that little fact, that light is a transverse wave, is the absolute key to everything we're talking about today. See, if its vibrations are going all over the place, up, down, side to side, that means we can do something really cool. We can filter them. We can actually control them.
Think about it like this. Imagine you're shaking a long rope up and down, making a nice wave. That wave is going to pass right through a vertical slot, no problem. But what happens if you then stick a horizontal slot in its path? Bam! The wave is completely blocked. It can't get through. And that simple idea, that's the perfect analogy for polarization. It's all about filtering.
So this whole process of filtering, of taking this kind of chaotic, messy, multi-directional light and forcing all its vibrations to line up in one single neat direction, that has a name. And you guessed it, it's called polarization. Okay, so most of the light you see every day, from the sun, from a light bulb, is what we call unpolarized. That just means its waves are vibrating in every possible direction. Up, down, left, right, and literally every single angle in between, all at once. It's a complete chaotic jumble.
But then, when that jumbled light hits a polarizing filter, just like our rope going through the slit, something amazing happens. Only the vibrations that are perfectly lined up with the filter can squeeze through. Everything else gets blocked. And what comes out the other side is plain polarized light. Now, all the vibrations are neatly marching in step, oscillating in one single direction.
And get this, here's a really wild consequence of all this filtering. Because that incoming, unpolarized light is vibrating randomly in all directions, a perfect polarizing filter will always block exactly half of it. No more, no less. So it instantly cuts the brightness by a perfect 50%. Kind of crazy, right? But you know what? Humans weren't the first to figure this out. Not by a long shot. Nature has its own incredible polarizers, and they're hidden inside some really special crystals. We call these anisotropic crystals. Now, that's a fancy word, but the idea is simple. Unlike regular old glass, their internal structure has a specific direction to it. This means they mess with light differently depending on the angle it's coming from. A great way to think about it is like the grain in a piece of wood. It's way stronger in one direction than it is in another. Same idea. So, let's take a trip back to 1669. There's the scientist Erasmus Bartholinus, and he's just kind of messing around with a crystal of calcite, and he notices something. Well, something that must have looked like straight-up magic. He takes the crystal and places it on top of a piece of paper with a single ink dot on it. And boom! Suddenly he's seeing two dots instead of one. The crystal had actually taken the single ray of unpolarized light coming from that dot and split it clean in two. And not just any two rays, two separate, fully polarized rays. This crazy effect is called double refraction, or if you want to be fancy, birefringence.
Okay, so if nature can pull this off with a simple crystal, how do we do it? How do we create and use this amazing effect on purpose? Well, it turns out there are a few really clever ways.
One of the easiest ways is something you see all the time, reflection, just bouncing light off a surface. When that unpolarized light from the sun hits, say, a flat road or the surface of a lake at just the right angle, the light that reflects off it becomes super polarized. And specifically, it's polarized to vibrate horizontally. And that horizontally vibrating light is exactly what our eyes see as annoying, blinding glare. One of the first natural polarizers that scientists really studied in detail was the gemstone tourmaline.
and it's got this amazing optical property, for sure. But here's a funny little aside. It was also once marketed as a health product. Yeah, people were selling it claiming it could help you with fat loss, reduce water retention, and even improve your mood. Go figure.
So this whole ability to filter and control light, it's not just some quirky thing scientists play with in a lab. No way. It's a fundamental piece of technology that you almost certainly use every single day. And you might not even realize it.
Let's go right back to that glare on the lake. Your polarized sunglasses? They're designed with vertical filters specifically to block that horizontally polarized light. That's how they work. But the applications go so far beyond that. Photographers slap polarizing filters on their lenses to make skies a deeper, richer blue. Engineers can use polarized light to literally see invisible stress points in glass or plastic before they break. Even chemists use it for things like measuring how much sugar is in a solution.
And what about 3D movies? Oh, the system is just brilliant. The projector is actually sending out two different images at the exact same time, but each one is polarized in a different direction, say one vertically and one horizontally. The lenses in your glasses, they're just polarizers too. They're like little decoders. One lens lets the vertical image through to your left eye, and the other lets the horizontal image through to your right eye. Your brain takes those two flat images and stitches them together, creating that incredible 3D effect.
So when you step back and look at it, by understanding and learning to control this one simple hidden property of light, we've unlocked technologies that literally shape our world. From something as simple as seeing better on a sunny day, to building safer cars and buildings, all the way to how we entertain ourselves. It really makes you wonder, doesn't it? What else could we achieve if we can control the very fabric of light itself?